everybody can profit from the conversation. I'm recording. Let me quickly. Okay. Okay, let me share my screen and then let's talk. So mainly you're interested in exam one, right? So this is basically an exam one review session. That was my understanding, but the main concern were, I think, Abigail, you had some additional questions, right? Which we can discuss afterwards.
Perfect, thank you.
Sure. Good. Okay. Let me just get organized here. I'm sure. I'm sure this one. This is the one. Okay. Okay, can you see my screen? Can you see the exam? So I put open the exam one. Can you also see my screen?
Yes.
Good. So, review. Okay, so we have data from a health survey. Data were obtained from a random sample of 2,000 people. So the N equals 2,000. A linear regression analysis was conducted in the following way: dependent variable serum creatinine, independent variable marital status, gender, age, race. So I think this is fairly self-explaining, right? So we have the different categories here, so we know what the respective reference values are. So reference category here for marital status would be currently married. For race ethnicity, the reference category would be non-Hispanic white. So we only see the betas that are deviating from 0 here. Okay. So now we are asked to calculate the residuals for a 70-year-old non-Hispanic white widower. So that would imply that we are essentially looking at a creatinine level of 1.15. His actual measured creatinine level is 150. So the squared residual essentially is here. We have, well, we do have the deviation, which is 0.35. So it's 150 minus 115, that's 0.35. And squaring this is essentially 0.12, oops. No. 0.1225. Let me open R, let me have something to calculate stuff with. Were there any specific questions to that question? I think that's a fairly straightforward one, right? Okay, I see nodding. Nodding is good. It's nice if you turn on the video, it's a little bit more interactive, so I appreciate that, Abby. Thank you. Okay. All right, so we have here, so I need that anymore. Okay, so 0.35, 0.111225. So now we're looking at the variance. So the variance of creatinine level in the sample was 0.2. What is the total sum of squares for the entire sample? Y bar is the mean of Y. So essentially we have, if we know that the variance is 0.2, we essentially have the variance being calculated as total sum of squares divided by n, right? So then essentially calculating the total sum of squares is not really that difficult. So you just need to calculate the variance multiplied by 0.2, right? So this essentially gives you 2000 multiplied by 0.2. That would be 400. The sum of squared residuals, now it's getting, yes.
Specific question. I'm sorry to interrupt.
No, please.
A little bit, but I was hoping you can go over question 12. I thought this question was like a little confusing. Maybe I didn't understand the concept well enough to answer it, but maybe.
Well, I thought we're gonna go through all questions, but we can specifically go through question 12. Okay. Okay, with RCT data, one usually compares the outcome between treatment arms, drug versus placebo. However, it's not uncommon for researchers to compare the outcome based on some other variables. Which are collected during the trial rather than the original treatment assignment variable of the RCT. In such a case, the nature of the investigation is changed from an RCT to an observational study. Consequently, one needs to explore and control for possible confounding for such comparison. Is such a conclusion true or false? What would you think? What's the thought process you had?
I put true.
Yeah. And why is it true?
I feel like we always have to control for confounding.
So an RCT essentially you mean to kind of take the influence of confounders out, right?
Yeah. Oh, so you do it the randomization?
You should do it by the randomization. But the story, what happens here is, it is not uncommon for researchers to compare the outcome based on some other variables, which are collected during the trial, rather than the original treatment assignment variable of the RCT. In such a case, the nature of the investigation is changed from RCT to an observational study, because you're taking the randomization out to some extent, right? Consequently, one needs to explore and control for possible confounding for such comparisons. So there are various reasons why the composition and during a trial could change. One of the major reasons is, for example, the patients drop out from a randomized from an intervention arm, right? Mm-hmm. So then you may have some disbalance in terms of some parameters, but it's in an intention to treat, there's not really a problem. But if you start adjusting them and controlling for variable, you are to some extent changing your randomization and the balance between the variables. So you mean to take some effect out. And you're changing the effect of the intervention per se.
By controlling for confounders and whatnot.
But confounders during the trial. So this is the specific question here. It is not uncommon for researchers. It's not. It's a tricky question. I agree there. But you need to think of it from that end. You take the confounding out, and Abby, that was your point that I said there's not going to be much on RCT, but that's kind of the common understanding of RCTs. You take with the randomization, you take the confounders out, and you take them out, but basically balance them according to the baseline variables. So if you had a disbalance between baseline variables, you would control for the baseline variables. But if you're controlling for whatever happens during the trial, and this is an important distinction, because once you start controlling for something that happens during the trial, you are diluting and you are affecting the treatment effect. And this is concept. Yeah, this is where it's tricky, and it's like it happens that the trials are being approached that way. To be honest, it's not the cleanest way to analyze randomized controlled trial data. So you have as-treated protocols and as-treated analyses. You have secondary and tertiary analysis, and sometimes researchers do that, right? And it happens.
So for example, just so I'm clear, if I was holding an RCT and drinking was a confounder, I can't tell people to not drink. I have to just let them drink.
Exactly.
Okay.
No, well, design the trial for me. Let's design it for me. What's the exposure? What's the intervention? And what is the control group?
Oh, okay. So the exposure would be maybe like a new diet pill, perhaps.
Okay, diet pill. Okay.
And
so that's the intervention. It's actually, yeah, exposure intervention, intervention for an RCT intervention is better. Okay, so you have a control group that gets a placebo pill, and you have an intervention group that gets the real diet pill.
Yeah.
Right. Okay.
And then we're looking to see if there's a change in like weight or BMI. But
okay.
If I like told people to not drink, then I think that would affect their overall BMI, and then it would like skew the results for like the total, like if we're trying to base it, or if we're trying to use that for like the overall population.
Well, if you tell them, if you only tell your intervention group to not drink, well, drink alcohol, or no. Okay, so you tell your intervention group to stop drinking beer, and your intervention group stops drinking beer, and the amount of beers they had, regardless of your recommendations, if you adjust for that, that would be kind of the distinction between as-treated and intention to treat analysis, right? And if you adjust for the amount of beers they drank, then the nature changes.
Yeah.
Because you're affecting the true effect of the intervention.
Okay, understood.
That's how it becomes an observational study, because you're trying to kind of see what was the effect I seen in my population, but it's not really going to an in vivo study anymore. So this is how I interpreted this question. I didn't put on the exam, so but this is the logical way of how I would go in my train of thought.
Okay.
So, I'm sorry. This was one that tripped me up also, because once I saw that it said observational study, in observational studies, we adjust for confounding.
Exactly, and that's what you're doing, right?
Is this one supposed to? What is the correct answer for this one?
True.
Oh, that's it.
Yeah, no, it was correct. It was the right. You had the right. I didn't disagree with your statement on true.
So wait, I think I got that wrong though.
Well, if you said true, then it was right.
Oh, after I took the test, it actually told me that I got it wrong.
Okay, then I need to yet create the exam. So this is on my to-do list for this weekend. So you get the results by tomorrow evening.
Okay. Cool.
Yeah. No, the tricky thing is it really an observational study? Yeah, it becomes an interventional study because you do have an intervention, but you're diluting that intervention effect.
Mm-hmm.
Yeah. Okay. So what other questions are there? Let's do it question specific first.
I was curious about the other RCT question about blocking. I was a little bit thrown off by, so I don't know actually which number that is. It's a free response one, so further down. Okay, that one's easy, but the 14. So like, just my understanding of blocking is like, if you have to choose from clear, distinct groups, like if you were like, I think of it in like educational research of like, if we are randomly choosing kids into either they get this intervention or they don't, but they're coming from 3 different schools, would that be a use for blocking?
That is a block, exactly. So whatever entity you have, the classical way is like environmental circumstances. So environmental circumstances, environmental constraints. So environmental constraints, so like a school, dialysis clinic, like in my world, a practice, or can even go further, can go from a treating physician to another treating physician. So whatever kind of changes the nature of that group you're looking at, that entity you're looking at. So that would be the answer I would have looked for, or what Professor Sang had in mind for this question.
For that question, I think the example I used was like agricultural blocking.
Yeah, that's the classical one, right?
Okay.
Yeah.
And like the way I've like thought about it was there's so many variables within the groups that we are not really looking for the, I guess, variance within the individuals in the group, but rather like the difference between each implemented whatever, like like when you have separate groups and you have a different type of intervention for them.
Yeah.
That like, would that work? Because I felt like I was trying to describe it in the prompt, but I wasn't sure if that came off clear enough.
Yeah. Okay. I'll keep your comment now in mind when I read your response. So you're right. So the classical example, and this is in the answer that I have here, it talks about Fisher, the famous statistician of the 20th century. So he had these agricultural blocks, and this is also that's mentioned in the books concerning that topic. So you have these blocks that are to some extent defined by environmental constraints. Analytically, these really matter because, just like you said, you have between variance and you have within variance, right? And now you really need to put your ANOVA hat on and think of it with the eyes of ANOVA, because this is essentially what will determine your F statistic that goes into your analysis in your regression models, right? And this is really why it matters. And this is really why you need to take these blocks into account, because if you have one block where the variance is large and one block the variance is small, you need to account for these differently in your model. And this is really the idea behind it. And this is why it's so important. And this is why you would then, and this is an adjustment factor, for example, that's often found, which does not render a randomized design into an observational design, because there you just take these differences in variance into account. And this is like a baseline adjustment. Yeah. Okay. I think that was a good thought process. Thank you. So what else? Any other questions? So 15 was a nice one, right?
If nobody else has questions.
Yeah, please, go.
Oh, just like as a clarification for number 16, you were talking about like the process of a scientific study, not like the like if it's what was the word? If it's able to be reproduced and stuff like that, or do you mean like, you know, building a hypothesis and testing it out? And because I wasn't sure when you were wording that, like
Pico.
Yeah, Pico, yeah. That was meant. Pico was meant. Population intervention. Pico.
Oh, Pico.
Population intervention comparison of outcome. And this is these are extremely important, because so again, so now I'm putting my researcher hat on. It's like the most important thing that you need to understand is like how to write a paper and how to read a paper. And these are really the 4 things you need to keep in mind when it comes to all analysis. That you need to kind of characterize the population. You need to understand what that population actually looked like, what the caveats with this population are. Then you need to understand, in the case of an RCT where you have an intervention, or in the case of a cohort study where you have an exposure only, case control study, let's forget that for now, but cohort and RCT are the most important one. For those, you need to understand what is the intervention or the exposure, how does that perform in the light of the population, and then the comparison. What am I comparing? How am I comparing it? What will that look like in the light of the outcome? What would I need to adjust for in that comparison? What will affect the effect of my exposure? And then lastly, the outcome per se. What is my outcome? How do I quantify it? How reliable is that metric? How reliable are the tools that I'm using? So these kind of things are really the most important things for a scientific study. And this is what this study was aiming for. So how would you have phrased it? Is it now clear, or would you have phrased it differently? I'm open for constructive criticism, and I definitely will pass this on to Professor Sang.
When I was like reading that question, I had two ideas in my mind. I was thinking, is this the process of the scientific study, as in like what should we do as in the action of it, at like, you know, because what I wrote like observe population, form a hypothesis, intervention, and then analysis. And I think that was like general enough for like a scientific study, but then there's other, I don't think it's like, because when you said elements, I wasn't sure if it's like what constitutes as a scientific study the process, or what it is, like what elements it has to be a scientific study, as in like you can replicate this experiment over again if it has like, you know, X, Y, Z. So I think it's just like the wording, like if it's, yeah.
So what would be better wording?
I have to think about that too.
I thought the exact same thing as you. I was like, oh, the 4 steps of a scientific study. And I was like, this is like, you know, like the high school, you know, like it's kind of like these 4, but so I think maybe like saying it through like a biostats lens, or through or like giving something about like it being specific to, because
action.
Otherwise it is kind of like, those are like everything that Kat mentioned are elements of scientific study, you know?
Yeah, what ties my hand there a little bit to be too lenient about it is that we discussed it in the very first class as the 4 elements of the scientific study.
Maybe like if you could clarify that we're looking for elements of like the process of it, rather than like what it is, like the process, like it's an action that you're supposed to be doing to do a scientific study.
Okay, so it's now my first language. when it comes to a process, I would have talked in the context of a process. I would have talked about steps or phases, but not about elements, to be honest.
I don't want to steps make sense.
Steps would have made sense, but again, we're writing elements, right? We didn't write steps. So an element is kind of a part of something as a whole, but it's not part of the process, which steps would have characterized the process. Element rather conducts or represents a kind of labors parts of a whole, rather than a process. Again, not my first language, but it's like that's I'm like I hope I come across like somebody who would give you those points, but this one I can't.
So you were looking for PICO specifically?
Yeah, PICO would have been the right answer. But it's a good thought process. So it's like you're not you show the participation, your outcomes are good, so you don't have to worry about it. But yeah, I think this one was not point on. Okay, so 16. Any other questions?
Can you review 11?
11, yeah. Okay, regarding the p-value of a regression coefficient of a binary variable in a confounding model, which of the following statements are true? It tells the difference of outcome between the two groups. It tells the difference between the outcome between the two groups is statistically significant. Okay. It tells if the difference of outcome between the two groups is practically different. Okay. It is a convention to use a value of 0.05 as significant level to distinguish if the outcome, if the difference of the outcome is statistically significant or not. Okay, that's a little bit of a trip. Okay.
I choose A and C.
It is A and C, yeah.
Okay.
So what the idea behind it was, and this is super important, you have to keep in mind with all analyses, and this is again where I put my big data hat on. So you get a significant difference, you get significant results for things that should essentially not being paid that much attention to than they sometimes are in some studies. If you have a large enough data set, you will get significant results for things that are not necessarily relevant. Okay. Well, they are still relevant. Okay, I'm backpedaling. They're still relevant, but they're not clinically important, not as clinically important than a larger difference. So the significance is sometimes really trumped by the difference per se. It's also, and this is true for a randomized controlled trial with an adequate sample set. But again, you have, for example, you have in the dialysis population, this discussion comes quite frequently where, with blood pressure medication, for example. Blood pressure medication are actually not super effective in the dialysis patients because they're fluid overloaded, which also affects the blood pressure, right? That kind of dilutes the effect of blood pressure medication, but they're still having significant effect. So this is where the discussion kind of becomes interesting. So what this means to kind of ask from you is an understanding that the practical difference or the practical significance of a difference or of a significant difference is not necessarily as important in comparison to the statistical significance.
Okay.
That was the idea that you distinguish between both. Does it make sense? Any other questions on that?
Oh, 11's clear to me. I can't remember I had, I think, one more question, but I just can't remember which one it was on. I have to.
Well, because we can't see the test anymore, but there was another select all that apply that I was hoping, actually maybe.
Is it that guy?
Maybe it was 9.
Well, we can, let's have a look at 9 first, unrelated to the previous question. Okay. Suppose the modeling purpose of the so-called following model, the so-called confounding model, is seeking the association between xi and yi. Okay. Well, okay, so this is the classical regression model. Okay, well, I is representing the i's individual in the data. I equals 1 to n. Ck1 are the confounders. Okay, so we see beta 0, beta 1, xi. Okay. XP. Okay, what are the correct statements about the error terms? It can represent the measurement error of yi. It could be considered as including other unmeasured confounders. Okay. We could assume the error term follows a normal distribution with constant variance, which we know, right? However, during data analysis, we need to verify the constant variance assumption. Okay, so we know already this one is true, right? When one plots the estimate of the error in the so-called residuals, for example, using histograms, such plot is always symmetric. bell-shaped unimodal, like a normally distributed.
For this one, I thought A, B, and C were all true, and that D, because it said always, and like if we have to check for it, doesn't that mean that there's a chance that it won't always have that normality?
Yeah, so the problem is it depends on the estimates, right? It's not necessarily unimodal. That's what Professor Sang is saying here.
And what about A and B? So D
A, B, and C are correct, right? So you have in the error term, so you have, it represents the measurement error of yi, which we know, right? So we're assuming that there's a measurement error entailed in yi that is reflected in the error term. You are considering all variables that are included on the right-hand side as being correctly, accurately measured. That's your basic assumption. It could be considered as including other unmeasured confounders, which is true because these are the ones that you haven't accounted for, that you haven't quantified, and this is contained in your residual error term. We could assume the error term follows a normal distribution with constant variance, yes. However, during data analysis, we need to verify the constant variance assumption. So we need to verify that. When one plots the estimate of the error term, so-called residuals, for example, for the sample using histogram, such plot is always symmetric bell-shaped curve, unimodal, like a normally distributed data. Well, it comes with the assessment. That's what he's saying here. It's not correct because we cannot assume that without having the assessment.
And why did it switch to E hat when before it didn't have the hat?
Because it's the prediction, it's the predicted error.
And then the one above it didn't have the hat. Should it have had the hat? Like
no, this one not. This is the over. This is not the predicted error. So
no, but in C.
So the difference between the predicted error is where you have, so it's the error that is normally distributed, right? But this, the residuals are the difference between the prediction and the actual data. That is not synonymous with the error per se.
Okay, and in point
the
C.
error is that this is the total variability, right? This is the total variability. This is the regression variability. So you need to distinguish between those two. This is why he exposited, and this is why this question is actually pretty tricky when you think about it. And this is also why this is essentially not necessarily unimodal, because this is essentially dependent on the coefficients.
Okay, I think I chose A, B, and C, but this one was the one I thought I got wrong.
Yeah.
But
no, with A, B, and C, you got it right.
Now I can't. So I guess we'll get the scores later. So I don't know which one it was that I got wrong.
Yes. No, but the trick is, and which you really needed to pay attention to, is it is EI hat minus EI. This is where the unimodal is not necessarily correct. But that is a tricky question, I agree. I do wholeheartedly agree. All right. Okay, clear now? EI and EI hat? Yeah, okay. It's not an easy test, not an easy exam. I'm curious to see the outcomes. Okay, in building confounding model regarding set I, a potential that one could fit a model without the unadjusted model. We don't fit the model at set I. The estimates, which of this following is correct? Beta 1 is always larger than beta hat 1. Is it not? Beta hat asterisk is always smaller than beta 1. Was it not? And beta, this is also clear, right? It really depends on the correlation and in which direction the correlation points. So when you take that into account, you need to take into account in which direction these two actually correlate. And that will determine whether it's smaller or larger. And this one we discussed. This one we discussed.
Can we go over the bonus questions? Because that I was just curious about.
Yeah. One in specifically. Okay, so this is block randomization. Talk about that. Talk about the out libraries for elements, bonus questions. Okay, the variable age is usually included in a model as a confounder. However, in certain cases, such a variable can be an outcome. Give an example where age is an outcome. Okay. Shoot the examples.
I forgot what I put down for that, honestly.
It's a good question. It's a tough question.
Age as an outcome.
Mm. Well, it's a mean question because it's a non-modifiable outcome. But what it could be is something which relates to age, right?
Okay. Well, for that one, I did some weird math, but then I remember that you can't, because like the coefficients can't really like that. I saw that you can't use individual coefficients for all those variables to predict for another one or something like that.
Can I say that again, please?
Well, I thought that like for the all the coefficients for each individual variable is specific to those variables, and you cannot use those coefficients to predict or manipulate to like find another coefficient, like to calculate one. But can you, or?
I think you're thinking too complicated here. You're trying to approach this in an arithmetic way, which is not what he meant.
Okay.
What was meant is that you have a variable age, which is a non-modifiable variable, as far as we know. Except for when you find the fountain of youth somewhere in South America, then maybe you get younger, but it's non-modifiable, right? So, and this is the tricky, that is why it counts as usually as an adjustment factor in regression model. So that means that if you have, I don't know, you want to see an effect of an intervention on cardiovascular disease, age is going to be a confounder, and you're going to take age out, as an example. Good. So now the question is, in certain cases, a variable that is classically only to be adjusted for, and is traditionally only treated as a confounder, can also become an outcome. So it goes from the right-hand side to the left-hand side. What could be one of these statistical or research examples that would make age an outcome?
Can I interject?
Absolutely.
I don't know if I'm right. And I said this because I had like 2 minutes left to write this answer, I think. But I wrote like something about like STDs and how it's more likely to affect a certain age group, like those in their 20s, than those that are like in their 70s.
Bingo. Yeah. Socioeconomic factors depend the age of a young girl getting her first STD, as an example. Or I don't know. age of the mother affecting the age of the fetus at birth. Smoking status affecting the age of the fetus at birth. Cognitive function and age and retired, I don't know, retired person gets in a nursing home. Something along these lines, right? That's what he meant.
So basically it could be like the age when an event occurred, right? Like
exactly.
Age at first signs of memory loss.
For example, yes, exactly. Smoking and memory loss. At what point is like smoker have earlier cognitive function decline, which is usually good.
And could you also, like, now I'm just thinking this, could you include like gestational age at birth, gestational age at birth?
Absolutely, yeah. Just everything that is kind of on, which gets this classic component. This is what he meant. It's like everything that's on the right-hand side. How do you get age that's classically on the right-hand side or on the left-hand side? What could be an example? That's what was meant. Okay, so, okay, same question here. Variable sex is usually included in a model as a confounder. In some certain cases, such a variable can be an outcome. Give an example.
In prostate cancer, how it mostly affects men, or it always affects men, right?
Once again?
Prostate cancer, or like breast cancer, how it's gender specific?
Well, breast cancer is actually not gender specific. Men can actually get breast cancer, believe it or not.
Most often, I think it affects women. So would that be the outcome?
Yes, that's true. That is true. That is wholeheartedly true. No, but so men actually have, so I forget what cells are basically, so there was one certain kind of breast cancer men can get to, and it was actually very malignant form. Like if men get it, it's really terrible. It's actually, it's quite a terrible outcome. So it is, but yeah, so there's a clear predisposition. So but it's a good example because essentially it could be then, okay, so who has the worst outcome, right? Are you more likely to be male when you die earlier from breast cancer? What could be another thing? Cardiovascular disease. Cardiovascular disease. So yeah, it's not a really clean example. But so there are differences. There are gender differences in terms of outcomes, which are mainly hormonally determined, lifestyle determined by various factors, or occupational factors. Like so, there are differences, right, in terms of outcomes that are to some extent found. What else?
But those ones still, like what you were just saying, that still seems like the gender is acting as like a confounder, that it's different between groups, but it's still not like the outcome.
Yeah. Yeah, you're right. Okay, let's go in the animal kingdom. So you have fish species that basically change their gender, right? So they can be either male or female. Let's go there. So you could put an example at like, so you're fishing 20 fish out of a pond, and it's November, and are your fish more likely to be male or female? Because there's a seasonal predilection whether they're male or female. Aha, got you. Okay. No, but it's so along these lines. It's like just be creative, right? It's like research is a lot about being creative, and it sounds weird to say that, but in many cases it's really creative thinking and thinking outside of the box. And the reason why I actually became a researcher was because I just traditionally don't really do well thinking inside the box and being pressed into. And this is why I fell in love with research, because it gave me kind of a setting, a professional setting in which I could think outside of the box. And I didn't have to think in labels and predefined pathways and tracks. So also with that example, I think it's good to kind of ask the questions. I actually like this bonus question, and it's not an easy one, but it's kind of thought inspiring. So being creative there was really the idea behind it. What examples? What other examples did you have?
I guess like along, I don't know if this is along the lines of like the animal one, kind of like, or like what gender it will be with like before a baby's born, like if there's anything that like determines what gender the fetus would be.
That is a very good one.
The clownfish.
The clownfish, yeah, exactly. Clownfish, a perfect example. Yes, absolutely. Clownfish actually changing their genders. Yes. That is a good example. They do. Yeah. So the whole thing was Finding Nemo actually. Modeling could have kind of be his own mom. So clownfish is a super example. There are other fish like that. I actually was not thinking of the clownfish, but the clownfish is actually a really good example because that's why Finding Nemo was kind of paradox. What else? Yeah, I like the predictors of sex because nobody really knows what's happening there. But there were some observational studies they had after. I have never. So there were some ideas about. I think that. So they had. No, I'm not going to say that, but this was just something that was communicated to me. I have never read the study per se, but I think there were some studies that claimed that. No, I'm not even going to go there. That was too anecdotal. Okay, I would need to read first. Now, because it's not really clear what really determines the sex of a fetus. No. I wouldn't know of any. Do you have any? Did you read any literature in that regard?
Just out of curiosity, since we're talking about variable as sex or gender, would there ever be like, this is just like purely curious question, like a quantifiable, any studies that have like any quantifiable way to determine how people identify genderly, like with their gender and stuff?
Well, that's extending then the possible outcome categories, right? So that's analytically a different methods that you would need to employ there. That would more go in the realm of like polytomous. It's analytically it's different, but again the identification versus the biologically. I think it's going well. It's going in two different directions, I believe, to some extent, right? It's a different research question, I think. But yeah, it's definitely something to keep in mind as well. Yeah. I'm not sure that. Yeah, so we have only done binary outcomes. So I think from the other end, we're kind of constrained to binary outcomes. So from that end, I would probably not go there yet. But I think you could definitely design research questions where you could also take gender identity into account. Absolutely. That actually could be interesting. I would be surprised that in the realm of psychology and psychometrics, there wouldn't be a study like that already. I don't know. Are you aware of literature in that regard? Actually, would be interesting. There must be something. I'm quite certain. I'd be very surprised there's nothing. You're muting it. I catch you saying something. But yeah, I'm quite certain that the plethora of studies up there. It's kind of a hot topic to some extent right now, right? It's quite extensively discussed. So I think it's definitely, there must be literature out there.
I think there was like in I think Germany had like this I thing about like LGBTQ identities and stuff like that, but literature was like lost.
Yeah, I'm not, well, Germany, okay. But traditionally, I wouldn't have thought of Germany being one of the pioneers in research in that regard. I would have rather thought it's going to be somewhere here in North America. But yeah, it's like, it's possible, definitely. Well, if you come across literature, please share it. I'd be interested. Always try to expand my understanding of whatever level and whatever topic. That's actually a topic I've never really investigated much. All right, so this is variable sex. Any other thoughts on the topic? If not, any other question that is interesting? I think the other ones that we went now. So these are kind of like the more arithmetic ones. This is like, yeah. So we can estimate rectify categories in the descending order. Yeah. So this is easy, right? Correct interpretation of intercept 57. This asks you to understand the reference categories, right? That x2 bit the binary variable for the most separated. Okay. Okay, that also doesn't seem to be too complicated. Was that a problem, this question? It just seems to question, I would need to think it through. What question is this? This is number 6. Why do we have to? No.
I was just hoping to also ask a couple of questions about the research note.
Absolutely. Okay.
I don't know.
Any further questions about exam 1? If not, then we can move on to the research note. I'm fine with that. We can also continue going through the exam. But if, well, we're talking about this one. This one was clear. Yeah, research note. Okay, so what question do you have?
Okay. I guess the first is if I'm going to use BMI as my outcome, should I, like it's skewed to the right? So there's like some BMIs in like the 70s and stuff. Do I need to exclude outliers and how would I do that if I did need to exclude them?
Did you look up other literature, what outliers they would exclude or not?
I haven't yet, but that would be a good idea. I mean, I was thinking like 70 as a BMI seems very like,
well,
it's
so
beyond what would normally be.
So I think outlier exclusion. I think this is like this is research pattern, right? But so I would take into account 2 main dimensions when I think about outlier exclusion. There may be, and I'm saying this pure more on an empirical level. The number 1 exclusion criterion I would employ is what is combinable with life, and I think what can actually live. And when I think of a body mass index of 70, that sounds like that is a typo, to be honest. But that is just thinking. Let's try. You're still seeing our studio right now?
Mm-hmm.
Okay. Let's think about BMI. So BMI consists out of weight. Let's make weight C from 1 to like 600, and that's kilo. And height from what's commonly found. Let's do like 1.2 to 2.2 by 0.1. Okay. If we were now, okay, for I in 1 to 600 multiplied by 10, so that's 6,000. We're doing now height is now 1.2, 2.9. This is actually, it should be, wait, hold on, no, that was actually not good. Why did this not work? Hold on. That's a sequence. 0.1.2, 2.5, 5, 2.1. Ah, that worked. Okay. So now we have, okay, so now we have 600. This is 6,000. So now let's calculate BMI. Okay, let's do this as a data frame. But that's not good.
Are you right now? Are you creating BMIs based off of?
Yeah, I'm trying to align. Let's. Well, I think we gotta do this a little easier. We gotta do this differently. Okay, so we have 14 entries now. 14 entries. We have now, hold on, for I in 14. Let's do this. Sorry, that takes me a little long. I guess.
No, but I mean, I was able to just quickly look. Like, I think people can live with BMIs up to 80. Have been like seeing
really?
like it's hard for them to be treated at a normal hospital and stuff. So it's like it's a very rare case, but it's like I don't think it's necessarily a mistake.
Okay. Okay.
So in
really,
that
80. I'm trying to arithmetically go through that. That seemed like something that was not compatible with life. No, but if you're saying you found 80, okay, so then I do the simulation on that. So, but that's an individual with like a good 400 kilos on 1 meter 60 centimeters, right?
It's hard for me to do it in the metric system rather than the.
Well, we're talking about 5'5" and 700 to 800 pounds.
Yeah.
So
it's a rare, I think it's something, and I think like the person may not live very long, but
it's like it's not impossible. It's like I think some rare examples of such dimensions to exist and to live. Yeah. Okay. No, but but this is now dimension number 1 as a reason for exclusion. Do you think that such a person kind of represents a norm in your population? May he live? Yes. Is he a norm? Is he somebody that you really need to consider in your distribution? Hard to say. How much of an outlier is it when you show the histogram?
I first did it with box plots, but I could try screen share.
Yes. Show me. No, it comes down to how many individuals do you have? If you have 3 individuals with a BMI of 70 in a data set of certain dimensions, probably not as important, I would think.
This, yeah, the screen sharing is disabled, but like it. There's
wait, hold on. I just enabled it. It should work now.
I can't share while you're screen sharing. Oh, okay. Now I should.
Oh, okay. Sorry.
So like, I don't know. These are the box plots, but it would be, you think better to examine it with.
Yeah. So when I look at that, it's like you have 2 greater than 60.
Yeah. Should those two be eliminated and leave the.
Yeah. I probably would I would cut it at like 60. I think that's probably, because it's also, when you look at the distribution, and I would suggest to do that as a histogram.
Okay. So it's almost like view it, but.
Yeah, and now there's the second dimension. So since we're looking at this already, the second dimension, which I would employ to consider the exclusion of outliers. So not much of a problem with linear regression. So at this stage of the analytic approaches, it's not that much of a problem. But if you get deeper into particularly longitudinal models and you start building fixed effect models, mixed effect models, there's sometimes situation where your model will not converge, meaning it will not become a model because your data is having too much variance to an extent, particularly in extreme settings. That just doesn't allow the model to kind of put an estimate out there for respective coefficients. And one way to get this under control is to cut out outliers, particularly in areas where you don't have enough of a sample size. And when you look here beyond 60 or less than 15, because you have one individual there, which is below 15, right?
Sorry, also.
So if you sort, if you just, yeah, exactly. So you have 13. So do you have, what's the age distribution in there? 70.
Everybody. I was doing all ages.
Mm-hmm.
Which that was the next question. And I'm also, these are more like personal questions and I should do them later. Like you can let me know. Was checking for the age, like it says to check for linearity in age, by like doing age groups. And I was hoping to get some help with that.
Well, we can look at that right now if you're comfortable doing this in front of the group. I think at this point we can stop recording because we're not talking about the HM1 anymore. Let me just, okay, I stopped the recording for now.